Today our topic is imperfection in solid. Now till now we have gone through the types of solid. The solid is divided in two types, crystalline and amorphous. Then we discussed the types of the unit cells which are present in the crystalline solids. Now after that we have studied about the packing in the crystalline solid. Right, and we have calculated the packing efficiency of different type of packed structure, BCC, FCC, and simple cubic unit structure, unit cell structures. Now we have come to know that in a crystal the unit cell are arranged in a proper order, in a proper definite geometry is there, and the lattice points are being occupied by the constituent particles. An ideal crystal. An ideal crystal is a crystal in which the unit cell, the crystal have got same type of unit cell at the same lattice points. The constant particles will be present throughout the crystal. But this type of setup is only possible when the temperature is absolute zero, that is 0 Kelvin. Right. So an ideal crystal, a crystal is an ideal only at absolute 0, right? That is the same type of unit cell containing same lattice sites throughout the whole crystal. But the actual scenario is different, right? So here there is a deviation of the arrangement of constituents particles in the crystal. In the 3 dimension, right? And the deviation is caused either due to the change in the temperature, the rise of temperature, or due to addition of certain impurities. Now this deviation, whenever the deviation of the arrangement of the constituent particles in the crystal in 3 dimension, it is called defect or disorder or imperfection. That means when the crystal no more remains perfect, we say it to be a imperfect crystal, right? And the imperfection can be due to the different change in the arrangement or due to the, or we can say the deviation will be either due to the change in the arrangement caused by rise in temperature, or it can be due to addition of impurities, right? Now the imperfection or the defect in solid are broadly divided into two types. So first is the point defect and second is the line defect. So imperfection in solid or the defects of solid in solid are broadly divided into two types. One is a point defect and another is a line defect. Now what is the point defect? Whenever the constituent particles in the space lattice or in the crystal lattice, right, if the defect is only across a particular point or particular lattice point, it will be known as a point defect. And when it is throughout the row, we know that we have got the arrangement in the 3 dimension, right? So when the defect is carried throughout the row, it will be known as the point defect, right? So in the point, so line defect, in the point defect, the disorder is around a particular lattice point, where the constant will be present. Whereas in line defect, the disorder is throughout the row of the crystal lattice. Now just see the point defect classification. Now the point defect is classified into vacancy defect and the interstitial defect. Now let me clear here that the two types, vacancy defect and interstitial defect, this is for the non-ionic solid. That means those solid which are non-ionic, right? So in the vacancy defect, now in the vacancy defect, what is there, that the some of the lattice are vacant, or we can say some lattice sites are vacant. I've just denoted here with this diagram here. If A, B, A, B, these are the different atoms which are being present, right? Or we are just depicting the circles. Now one or two of the particles or the sites will be missing from their place, right? So if it is missing, then what will happen? This vacant site is formed when the crystal is been heated. Therefore, it is also known as thermodynamic defect. And second thing is that here the density of crystal, what will happen? It is going to decrease, because here we can say that the mass of the crystal is going to decrease because one of the side will be missing. So finally what will happen? Density mass upon volume. So mass is getting lowered down. So finally what will happen? The density of the crystal is going to decrease. Now second is the interstitial defect. Interstitial defect, here if just we are showing it by representation here, what will happen? Here the interstitial site, this one is the interstitial site, is been occupied by the element here, by the particle here, right? So what will happen as a result? That we can say that when the interstitial site of crystal is occupied by the atom, right, it will be known as interstitial defect, and the consequence is that here density slightly increases, right? Now here again I'm telling that the vacancy defect and the interstitial defect, this is we are going to study under the heading of non-point defects in the non-ionic solid. Now it is point. Why? Because it is occurring at a particular point, around a particular point. Here also it is only around a particular lattice site, a particular point. It is not carried out throughout the row. That's why it is not the line defect, it is the point defect.